Welcome to AI Code News Channel.
Welcome to this deep dive explainer. If you've been tracking the frontier of open source AI, you've probably been waiting for a model that can genuinely go toe-to-toe with the closed source giants. Well, that wait is over. Today, we're breaking down the architecture of Ornith 1.5. It's a massive open source model that isn't just catching up, it's actively matching Claude Opus 4.8. For developers, having an open source model hit this tier is a massive paradigm shift. It means frontier-level capabilities are no longer locked behind proprietary APIs. But honestly, what's truly fascinating isn't just that it reached this level, it's exactly how it got there. It uses a continuous cybernetic engine of self-improvement. 86.1. Just let that number sink in for a second. That is the staggering score achieved by the 397 billion parameter flagship Ornith 1.5 model on Terminal Bench 2.1. This instantly establishes its heavyweight status. And remember, Terminal Bench isn't just some simple Q&A test. It evaluates models on real-world, highly complex agentic coding tasks where the AI actually has to navigate multi-step software engineering problems. Hitting an 86.1 here is huge. It proves Ornith 1.5 can handle the most demanding environments we can possibly throw at it. Okay, let's look at our roadmap for today. First, we'll cover the Claude Challenger, then dive into the engine of autonomous self-improvement. After that, stages 1 and 2, focusing on tasks and scaffolds, followed by stage 3 on GRPO rollouts. And finally, we'll look for the proof in the data. All right, section 1, the Claude Challenger, moving beyond handcrafted data. So looking at the old methodology, like what we saw in previous generations such as Ornith 1.0, you really had to rely on fixed, human-curated tasks and manually designed grading harnesses. It was a completely static training distribution. And the core problem with human-curated data, it's incredibly slow, it's intensely expensive, and it's fundamentally bottlenecked because human annotators max out at a certain reasoning level. I mean, an AI can only learn what a human explicitly teaches it, right? But Ornith 1.5 flips the script entirely. It actually acts as its own curriculum designer. We're talking about a self-generated curriculum and auto-evolving scaffolds. It completely sidesteps that human bottleneck by synthesizing its very own progressively harder learning environment. Moving on to section 2, the engine, autonomous self-improvement, and how we build the loop. This right here is the closed cybernetic loop that makes Ornith 1.5 such an absolute powerhouse. The key word you need to remember here is autonomous. A human is completely removed from this loop. It all happens in 3 really tight synergistic steps. Step 1. The model proposes progressively harder, totally new tasks that intentionally expose its own capability gaps. Step 2, it generates task-specific scaffolds, so it's essentially creating the instructions, the tools, and the exact grading rubric for the problem it literally just invented. And then step 3, it produces solution rollouts, attempting to solve that very problem it just set up. Because these 3 steps happen continuously in a closed loop, the model is autonomously pushing its own training frontier forward. It's constantly generating the exact data it needs to get smarter. Section 3 now, stages 1 and 2, tasks, scaffolds, and the math of the curriculum. The mathematical precision behind generating these tasks relies on 3 very specific signals. First up is validity. Basically, is the question actually coherent and mathematically solvable? It acts as a hard gate. If it's not valid, it gets 0 reward. Second is frontier difficulty. This is brilliant. The system literally looks at its own empirical success rate and targets a success rate of exactly 0.2, or 20%. This means it actively favors generating problems that are highly challenging but still just learnable. If the model gets too smart and starts solving a task 90% of the time, the reward for generating that task drops, which forces the model to invent harder problems. And finally, novelty, ensuring it doesn't just spam variations of the exact same question to artificially pad its stats. Once that task is proposed, the model has to build a scaffold, or a harness, to actually grade it. And just like the task, this harness is mathematically rewarded. It needs task alignment to ensure the test accurately matches the prompt. But crucially, it needs reward fidelity. The grader has to be sophisticated enough to tell the difference between a genuinely excellent answer and one that just happens to look right on the surface. And building directly on that is the third signal, hack resistance. Look, we all know AI models are notorious for finding lazy shortcuts to achieve a goal. This system explicitly rewards the scaffold for being a strict, cheat-proof grader that utterly prevents the solver from using any kind of reward-hacking behaviors. Next up is Section 4, Stage 3 GRPO Rollouts. It's time to take the test. So conditioned on the generated task and that unhackable scaffold it just made, the model actually tries to solve the problem. This is what we call the rollout. The model is scored for success, but it optimizes using Group Relative Policy Optimization, or GRPO. And here is exactly why that matters so much. By generating a whole group of different potential solutions and comparing them against each other, the model isn't just figuring out the right answer. That comparative reward actually propagates backwards across all 3 stages. It teaches the system how to adjust its internal parameters to not just produce better solutions, but to generate more useful training tasks and to construct more effective grading scaffolds in the future. It literally learns how to teach itself better. Finally, Section 5, Proof in the Data, Validating the Engine. And this brilliantly illustrates the results. We are looking at the flagship 397 billion parameter Ornith 1.5 going head-to-head with Claude Opus 4.8. When looking at this heavyweight class, it's really crucial to understand the context of what these benchmarks represent. On SWE-bench verified, Ornith hits 86.0 compared to Claude's 85.8. Matching Claude on SWE-bench means it is doing real, heavy-lifting software engineering, navigating repositories, debugging complex code bases, and writing functional pull requests. It isn't just answering trivia, it is going toe-to-toe with a top-tier proprietary model in highly complex agentic reasoning. Breaking that down a bit further, the margins here are just incredibly tight. On GPQA Diamond, Ornith scores 92.8 to Claude's 93.6. Keep in mind, GPQA Diamond is famously brutal. It requires PhD-level expertise in physics, chemistry, and biology just to solve. Scoring a 92.8 is an astonishing feat of reasoning. On agentic benchmarks like Toolathon Verified, it's 71.2 to 76.2. On DeepSWE, 56.0 to 59.0. Ornith 1.5 is consistently operating right at the absolute frontier of what artificial intelligence is currently capable of doing. But what's equally impressive is how flawlessly this autonomous self-improvement architecture scales downwards. The 35 billion parameter model significantly outperforms similar-sized peers like Qwen 3.635b, and it even dominates dense models like Gemma 431b. For context, a dense model activates all of its neural parameters for every single token, making it computationally super heavy, yet Ornith's architecture still pulls ahead. The exact same story plays out with the highly compact 9 billion parameter model, which matches or exceeds those massive 30+ billion parameter dense models. Speaking of that 9B model, there is a highly technical, completely surprising fact we have to cover. The development team utilized cutting-edge quantization techniques, essentially mathematically shrinking the model's precision without breaking its brain, to compress this 9B model down to just 1.5 gigabytes. We are talking about a model that beats 30 billion parameter systems, and it's small enough to deploy locally and natively on an iPhone or an iPad. You literally carry frontier-level agentic coding capabilities right in your pocket, completely offline. It's wild. Ultimately, this quote from the release captures the whole story perfectly. Ornith 1.5 continually expands its own curriculum and adapts its problem-solving strategies, driving sustained capability gains. It proves that the era of relying solely on massive farms of human annotators to write training data is ending. The AI can write its own textbook, give itself the exam, grade it strictly, and get significantly smarter from the process. Which leaves us with this final massive thought. If an open source model like Ornith 1.5 can already perfectly design its own curriculum, set its own difficulty frontier, and strictly grade its own tests today, what exactly limits how fast it can teach itself tomorrow? The engine of autonomous self-improvement is officially running. Thank you so much for joining me on this explainer, and keep an eye on the frontier.